Hello, everybody. This is going to be a sixth grade skill that really helps us in seventh grade pre-AP math. It's going to be basically combining like terms. Now, if you look at the screen there, it's going to show you generating equivalent expressions. Now, these are three terms that are super important for us to know when combining terms. The vocabulary term terms, okay, which would mean that every single one of these items here that are separated by your plus symbol are going to be terms. Our coefficients, which would be in green here, okay, those are the numbers that are associated with our variables. In this case, we have variables y squared and x. And then our like terms, these are things like 3y squared and 2y squared. The variable is the same, so therefore they would be like terms. So x is not going to be like y squared, so 3y squared and 2y squared would go together. Okay, so I'm going to show you what that looks like on paper. Now, one of those properties that we learned in sixth grade, like the associative property and the commutative property and the identity property. The distributive property is going to be super, super, super important to our understanding of the equations unit that we are currently embarking on, where we have variables on either side of the equal sign. So it's going to be super important that you know how to do that. It's going to be super important that you realize or remember your combining of integer rules, etc. So I have a video about combining integers so you remember, but go take a look at that just in case you want a refresher. So if we take a look at our paper here, again, combining like terms. This is a refresher for my seventh grade pre-AP students. The TEK that we will be using this with is 8.8C. However, it is a review of 6.7D, so it's 2 years ago that this particular TEK first came around, or it was heavily emphasized for us to know. Now, a lot of the properties, though, we have been learning since, say, 4th or 5th grade. So, again, simply a review and a refresher. So if I were to take a look at this expression, 7x to the fourth minus 5x to the fourth, some of you parents that may be watching, you may say to yourself, I don't quite understand what's happening there. The only thing that you really need to be concerned with is you understand that these two variables are the same, and really the only thing that I'm dealing with and comparing are the coefficients. So 7x to the fourth minus 5x to the fourth will simply be 2x to the fourth. I've told my students before that what you need to really be concerned with is basically the coefficients that go along with that. As long as I find two variables that are the same, I can properly compare them, and all I need to be worried about would be the coefficients. So in this case, coefficient 7 minus 5, it's going to be 2, and then I just carry my variable over. So what if I wanted to go backwards, though, and I wanted to pull something common that both of these share out and use the distributive property to do that? Okay, so I'm going to pull out x to the fourth. I'm going to put that on the outside of a set of parentheses. Now, whenever I use the distributive property, I want you to think multiplication. If I can spell that. Okay, think multiplication. So if I were to multiply this by something else, and in this case, it would be 7. So if I multiply 7 times x to the fourth, that's going to give me 7. I'm going to separate that by my operator of the subtraction symbol. Okay, the reason that I'm doing that is because this appears here. So basically what I'm trying to do is I'm trying to put two different numbers inside of these parentheses where if I were to multiply it by this and multiply it by this, I'm going to get an equivalent expression. So in this case, that would be 5. So if I were to multiply 7 times x to the fourth, that becomes 7 times x to the fourth. If I multiply x to the fourth times a negative 5, that's then going to become negative or minus 5x to the fourth. So do we see how that's just going backwards? All right, let's move on to this next example. This is truly using the distributive property. The distributive property is where you take the number that is on the outside of these parentheses and you, quote unquote, distribute it to each of the terms inside of the parentheses, okay? And then we're gonna work on simplifying by combining anything that we can. So again, I'm gonna write 3y squared. That is just gonna carry over. I'm going to distribute, meaning multiply. 3 times 4 y squared, okay? I'm going to distribute that. That becomes 12y squared, okay? Because I'm simply multiplying these two numbers and carrying my variable with it. The variable is going to be y squared minus, and if I distribute to each of the terms, and when I say term, I mean each part of the expression, okay? This is a term, that is a term, this is a term, okay? So when I distribute this value, 3 times 2, or 3 times negative 2, excuse me, that's going to become negative 6. So now, I'm not quite done though, because I then need to combine my other like terms. So this and this are common, okay? Or like, I should say. So because these two are like, all that I have to worry about, because if I just had 3 plus 12, what would that be? It's going to be 15. But because of the fact that I have these variables to go along with it, it's then going to become 15y squared minus 6. That's simplified using the distributive property. Another use of the distributive, and I apologize for my handwriting, property. Next, excuse me, I'm going to use the distributive property one more time. I'm going to remember whenever you have a number that is on the outside of those parentheses, that's telling you, that's shorthand, that's math shorthand. And I'm your translator at this point. That's math shorthand to multiply that number by what's inside of the parentheses. Okay, so let's see what that looks like. We have 0.5 x to the fourth. We can have a coefficient that is a decimal. Okay, so don't worry about that. I'm then going to multiply 0.5 times negative 3. I want somebody to do that. I want everybody who's watching to do that. I know when I multiply a positive and a negative, I should result with a negative. So that's going to be 1.5, okay? And then I'm just going to continue on with the expression and add 12 to that. So now I'm going to combine everything that I can. There's nothing else that I can combine that's x to the fourth, okay? But what I can do is I can combine these two numbers. I'm going to combine a negative 1.5 and a positive 12. So this is restated as 0.5 times x to the fourth, okay? Now, this becomes then 10.5 because, again, when I add a negative 1.5 plus 12, it's going to give me 10.5. So that is 10.5. So my final expression is going to be 0.5 times x to the fourth plus 10.5. Okay, so now you guessed it, this one's going to be fairly simple. I think that this one is simple to look at. If I only were looking at, say, 2 and 3, if I were adding those, what would that become? You guessed it, 5, but I'm not adding just 2 plus 3. I'm adding 2x plus 3x, which becomes 5x plus what's left over, plus 4. Okay. Now, this was just a simple tutorial for combining of our like terms. Again, this is a skill that came from directly from the 6th grade book, but this is something that has been happening at some level since maybe 4th or 5th in terms of having awareness of the properties and knowing how to work with them. If you have a question about this, play the video back. If you still have a question, come to class with a specific question. If you still have a question, after that, come to tutorials. Come prepared with questions. I am more than happy to answer them. Remember, that's every Tuesday and Thursday. And as always, I will see you in class tomorrow.